There are practice problems in your textbook which are great for learning these rules of logarithms. You know, they're just exercises, and I'll do a couple of them here. And let's take, for example, the log. Whoops, not b, but log, L-O-G, of, let's say a base. Let's go with base 2. A base 2, and I'm going to multiply 3 on that side. So 3 log a base 2 minus 4 log b base 2 minus 2 log c base 2. And the exercise here is to combine this into a single logarithm. So that's what I'm doing in this topic, combining these expressions into single logarithms. All right, well, I'm going to use the power rule first of all. The power rule says that a power of a log can multiply the logarithm. Well, you can work in reverse and literally take these coefficients and make them powers of the exponents. Powers, I'm sorry, of the bases. All right, so this is going to be log a to the third power base 2, log a to the third power base 2, minus log b to the fourth power base 2, minus log c to the second power base 2. All right, so that made all these have coefficients of 1. Now, as long as you've got that, then we can now invoke the sum and difference rules. In fact, I'm subtracting both of these. That means these are going to appear as denominators. So I can combine this into one logarithm, the log base 2 of a cubed over b to the fourth c squared. There you go. So it was possible to combine this into a single computation. And so if you look at it backwards, it might be, potentially could make more sense. Going backwards, I have a difference here. I'm sorry, a division, and so the difference rule of logarithms means I'm going to take this log, subtract that log, because we're dividing them. That led us here, and then the power rule gave us the coefficients over here. All right, I'm going to erase the board and do one more of these examples. Our next example, I use natural logarithms, and I'm only using with one variable here, x. So it's 1/3 natural log of x plus 3 times natural log of the square root of x minus 1/2 natural log of x cubed. And our instructions here, I didn't write them down, but the instructions are to combine this into a single logarithm. Okay, well, and by the way, this sort of stuff we're doing here, we're practicing, going back and forth between combining into a single logarithm or splitting them apart. I know you would see this in parts of calculus. There's a type of technique in calculus called logarithmic differentiation, and there may be some other places there where these rules are useful. So people will still use this stuff. All right, well, I'm going to get coefficients of 1 from my logarithms, because I cannot use the sum and difference rules in logarithms until the coefficients are all 1s. Well, to do that, I need to use the power rule. So I'm going to make these numbers exponents. All right, so this is going to be natural log of x to the 1/3. Natural log x to the 1/3. And you might think of that as a cube root of x, but I think I'm going to keep it in fraction form here. Now this is going to be natural log square root of x to the 3rd power. But let me think about that as the natural log of x to the 1/2 to the 3rd. So I replace square root of x with x to the 1/2, and then I'm going to make 3 the exponent of this quantity here, because of the power rule of logarithms. And over here, minus, here I've got natural log of x cubed, and then the power rule says that this gets raised to the 1/2 power. All right, so you can see that this 1/3 went up to here, this 3 went up to there, and this 1/2 went up to there. So what do we have? This is the natural log x to the 1/3. And here, if I take out my parentheses, I have plus natural log x to the 3/2. And then here, same thing. Multiply your exponents. This is minus natural log x to the 3/2. Now normally we would, combine this into a single log where we're multiplying these x's together and dividing by this x. But I see that I've managed to create a problem where these terms just simply cancel. These literally would divide off if we combine them together. In fact, let me write that out. This would be, if you use the sum and difference rule of logarithms, this would be x to the 1/3 times x to the 3/2 divided by x to the 3/2. And the point I was making is that these are going to cancel off. They'll cancel off here. They also cancel off immediately there because one subtracts from the other. So in either case, you end up with the natural log of x to the 1/3. So there we go. It's simplified. Now our next topic, we're going to start with something complicated and go in the reverse direction. We're going to break it apart into separate logarithms.